Right. Binary numbers. In binary number systems, how many symbols are there? 0 and 1. 0 and 1. Binary number 0 and 1. There are only two symbols. It can be a 0 or it can be a 1. Right. So, the binary number can be a number like this. So, there are only zeros and 1. When it is binary number, normally we use the base. Base means the number of symbols for that binary number, right? The base is for this binary number, the base is, what is the base? 2, right? In a binary number, we write the base 2 like this. Is closer to the number and little bit down we write the base. Normally we write the base as this. So as we know, for a binary number, base is 2. Therefore, we write the base as this. Right. Okay. Then when it is a decimal number, what is the base to? Yes, 10. Because there are 10 symbols for decimal number. Decimal numbers are the numbers that we are normal day-to-day life using numbers. It is 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 to 9. There are 10 symbols. So the decimal number can be, let's say 34. 34 is a decimal number because it is 3 is inside that range. 0 to 9. 3 is inside that range. 4 is also inside that range. Therefore, this is a decimal number, right? Therefore, we write the base like this. The base is 10 in the decimal number, 2 in a binary number, right? Likewise, we write the base like this. Base. Okay, you can write this down. Binary number base, decimal number base. Right? If we take octal, now I am writing about a octal number. Octal number also can be in the range of 0 to 7, right? 0 to 7 means it can be 32, but the base should be 8, right? So only we can understand whether it is a decimal or whether it is an octal from the base, right? So the base should be there. Otherwise, we can't understand whether it is a decimal or whether it is a octal. And hexadecimal, let's say 4E base 16. Don't bother very much about these two things, octal and hexadecimal, because they are not in your syllabus. You have to only consider about these number systems. Okay.
Do I need to copy down the octal and hexadecimal one?
Yes, yes. For example, you can write this down, but this is not necessary for you, but for get an idea about the base. For octal, the base is 8, hexadecimal base is 16. You can write this down also, right?
Okay.
Now I am going to discuss about decimal numbers. Decimal numbers 0 to 9, base is 10. 0 to 9 symbols are there. The base is 10. Right? Then I am going to represent a decimal number 34. Decimal number 34. The base is 10. I am going to represent this number in a counting frame. ගණක රාමුවක මම මේක represent කරන්න යනවා. Right? ඒක කරන්නේ මෙහෙමයි. There are only two numbers. Therefore, we have only two positions, right? In here, in counting frame, we take this position as positional value, right? Because this is to the base 10, in this case, positional value here is 10 to the power 0 is the positional value. Then here 10 to the power 1. In a counting frame, I am going to represent this decimal number in a counting frame. This is the way we get the positional value or the value of this place is, because this is 10 base 10, we get this as 10 to the power 0, and from right to left 10 to the power 0, 10 to the power 1. if there is a, let's say, if there is a number here, let's say 1 or 2, right? We have to write another axis, right? So the position value of this place is 10 to the power 2. Likewise, 0, 1, 2, 3, 4. It is increasing from right to the left. Increasing right to the left, starting from to the power 0, right? Okay, in this position value, right? In this position value, now I am going to represent this value in counting frame. In this 10 to the power 0 position value, there is number 4. There is number 4. So I draw 4 circles. 1, 2, 3, 4. There are 4. 10 to the power 0 position, there are 4 circles, right? Then this is 10 to the power what? 10 to the power, this position, 1. 10 to the power 1. What is the value? Value is 3 there. 1, 2, 3. Right? If there is another number, then 10 to the power 2. And we likewise, we draw the circles according to that value. If it is 1 is there, we draw 1 circle. This is how 34 to the power 10 represent in a counting frame. Right? 10 to the power 0, 10 to the power 1. This is a positional value. In 10 to the power 0 position, there is only 1, 2, 3, 4. 4 numbers. 10 to the power 1 position, there are 1, 2, 3. This is how we represent 34 to the power 10 in the counting frame. You can write this down. Representing 34 to the power 0, 10 in the counting frame. You can write as that. Representing 34 to the power 10 in a counting frame. This is how we represent. Okay. Right. This is how 34 to the power 10, sorry, 34 to the base 10 or decimal value representing the counting frame. Now I am going to expand this 34 to the base 10. I am going to expand this decimal value. The meaning of expanding is, I'll give you the technique how this is going to be expand. The reason you will understand later, right? Why we expand this, right? 34 to the base 10. How we expand this? how we expand this equal. This is the way we expand this, right? Number 3 multiplied by positional value, related positional value, right? The related positional value is here 10 to the power 1. 10 to the power 1. Done, right? 3 into 10 to the power 1. We put a bracket here. Okay. Then plus, only you need to get the idea of how the technique, how we expand this, right? Later on, you will understand why we expanding like this, right? 10, 3 into 10 to the power 1. Then the other number 4 into related positional value. What is the value? 10 to the power 0. This is how we write this. 3 into related positional value, 4 into related positional value, right? Then we are going to 3 into 10 to the power 1. How much? How much? 10 to the power 1 is 10. 10 to the power 1 is 10. Let's say 10 to the power 1 is 10. 10 to the power 2 is, that means 10 into 10. 100. 10 to the power 3 is 10 multiplied by 10 multiplied by 10. That means 3 times. So 1000. Right. So likewise, 10 to the power 1 is 10. So we get the 10 here. We use bracket because when we doing the calculation, you will be messed with these numbers. That's why we use brackets, right? Then 4 multiplied by, what is the value? 10 to the power 0.
0.
No, Puta. This is a mathematical theory, right? Let's say 2 to the power 0, 3 to the power 0, 4 to the power 0, 6 to the power 0, 7 to 8 to 9 to 10 to. For any number, right? Power 0, not multiply by 0. Power 0 equal 1. Power 0 equal 1. Power 0 equal 1. Right? 10 to the power 0 equal 1. 100 to power 0, 1000 to power 0 equal 1. For any given number, power 0 means, what is the value? 1. This is not only related to ICT, this is a mathematical theory, right? This is a mathematical theory. Remember this very carefully. 10 to the power 0 means not 10 into 0. This is 0. 10 into 0 is 0. This is 0. But 10 to the power 0 is 1. That is the difference, right? This is very important. You can write this anywhere if you want. 10 to the power 0 is 0. 10 to the power 10 into 0 is 0. 10 to the power 0 is 1. This is not only for 10, for any given number. For any given number. In generally, let's say we take a letter y. Y into 0 is 0. Y into 0, y to the power 0 is 1. This is a general equation. Right? Remember this. Right? Therefore, what is the value here? 10 to the power 0. To the power 0. How much?
1.
1, yes. Right, that's it. Okay. This is how we expand. Right. 3 into 10 means 30. 4 into 1 is 4.
4.
Then total is 34 to the base 10. That is what we get by expanding this decimal number. So we get the same number, decimal, in decimal form, right? We get the same number. This is how we expand, right? Right. Write down the expansion of 34 base 10 is like this. Expansion of 34 to the base 10. Write this down. Okay. Shall we do another example? (52 to the power 10). We need to do the expansion and we need to, let's say, I'll put another number here, right? 252 base 10. I need the expansion and the way I am going to represent this in a counting frame. Since there are 3 numbers, we have to take 3 axes. Right? There are 3 numbers, therefore in the counting frame there are 3 axes. So, can you tell me what is the position value here?
10 to the power 0.
Very good. 10 to the power 0. Here?
10 to the power 1.
10 to the power 1. Here?
10 to the
10
10 to the power 2.
Yes, very good. 10 to the power 2. That's how we represent this. And in the 10 to the power 0 position, how many numbers are there? How many numbers are there?
2.
2, yes. This is the 10 to the power 0. This is the 10 to the power, sorry. 10 to the power 0, 10 to the power 1, 10 to the power 2, right? In 10 to the power 0 position, there are only 2. 10 to the power 1 position,
5.
5 years. 1, 2, 3, 4, 5. 10 to the power 2 position, there are only 2. Yes, this is how we represent this number in counting frame. Good. Now I am going to expand this number. I am going to expand this number. I will write it here, 252 into 10. I am going to expand. Get the first number, 2, multiply by position value. What is the position value for 2? The first 2.
10 to the
10.
power 2.
Yes, very good. 10 to the power 2, and we put the bracket. Then second value, 5 into 10 to the power
1.
what? Yes, very good. Plus 2 into 10 to the power 0.
0.
Right, very good. That is how we write. Now, 2 into 10 to the power 2, how much?
20.
No, Puta. 10 to the power 2 means 10 multiplied by 10. How much?
100.
100. 100. Power 2 means not multiply by 2. Power 2 means 10 into 10. If there is 3, 10 into 10 into 10. Right? Okay. Put the bracket. Plus 5 into 10 to the power 1. What is the value?
10. 7.
Huh?
10.
10, 10, yes. 10. 10 to the power 1 is 10. 2 into what? What is the value of 10 to the power 0?
1.
Huh?
1.
Yes, 1. Very good. Okay. Then further we expand this. 2 to the power 100 means 200 plus 5 to the power 10 means 50. 2 to the power 1 is 2. Then 252. This is how we expand this 252 to the base 10. Okay, you can write this like previous one. Okay. This is how we expand. We are going to discuss about these kind of questions later. Why we write these kind of expansion, right? This is how decimal numbers are representing counting frame and how the decimal number is going to be expanded, right? Then I am going to discuss about binary numbers. Binary numbers. Binary numbers can be 0 or 1. 0 or 1. We also we tell this as binary digit. Binary digit. Binary digit. If someone asks what is a binary digit, we call it as binary digit is, it can be a 0 or it can be a 1. Binary digit, right? We call it as binary digit. So binary digit can be a 0 or binary digit can be a 1. So there is a short form for this binary digit. That is, we take B from this binary, B letter, and digit letter, in digit word, we take IT, B and IT, right? So we put this together and we call it as what? What? Bit. So what is the value of a bit? 0. It can be a 0 or it can be a 1. So bit can be 0 or bit can be 1. So in the computer, there are only bits. There are only bits. So bit can be a 0 or bit can be a 1. This is how the bit word came. B from binary, IT from digit. Then bit word came. So bit can be a 0, bit can be a 1. This is how it came. Write down binary numbers, then write down how the bit word came. Binary digit is a 1 or it can be a 0. Therefore, the bit also can be a 0 or can be a 1. Right? This is very important how the bit came. It is easy to tell, rather than every time, rather than talking about binary digit. So it is easy to speak, easy to tell, bit, very simple, rather than binary digit, right? Okay?
Okay, sir.
Okay, no?
Yes, sir.
Right. That is how the bit word came. Right. Now I am going to do the same task as we did in decimal numbers. This is binary numbers. Let's say 1101. 1101. This is a binary number. So we take the base as 2. This is a binary number. How many bits are there?
Four,
How many bits?
four,
Oh, yes. 1, 2, 3, 4. 4 bits are there. Because we know bit can be a 1 or bit can be a 0. So there are 3 ones and 1 0. So there are 4 bits. Right. Then I am going to represent this number, binary number, in a counting frame. Since there are 4 bits, I use 4 axis, right? Like in decimal numbers, we are going to put position value here. Here. There should be position value. In this case, what is the position value here?
2 to the power 0.
Very good. 2 to the power 0. In decimal, we got 10 to the power 0. In binary, 2 to the power 0. Here,
2 to the power 1.
1. Here,
2 to the power 2.
2. Here,
2 to the power 3.
yes, very good. Right. In 2 to the power 0 position, let's say here 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Right. In 2 to the power 0 position, there are only 1. So I draw one circle. Right. In 2 to the power 0 position, sorry, 1 position, there is no value, 0. 2 to the power 2 position, only 1. And 2 to the power 3, only 1. This is how I write this in a counting table. This is how I represent this number in a counting table. Write this down. Yes. Okay. Give me a second. Right. This one also I'm going to expand like decimal numbers 1101. Right? I'm going to expand this. How? As previous examples. Now this number, top left corner number into the position value. What is the value?
2 to the power 3.
Yes, 2 to the power 3 plus 1 into
2
2 to the power 2. Right, very good. 0 into
2 to the power
1 and 1 into 2 to the
1.
power
2 to the
0.
power 0.
Can you see here? What?
Yes, sir.
Right. Now 1 into what is the value of 2 to the power 3?
6.
No, dear. 2 to the power 3 means 2 into 2 into 2. 2 into 2 means 4. 4 into 2 means 8. Right?
Okay.
Not 2 to the power, not is 2 into 3. This is wrong. This is wrong. Right? This is how we write 2 to the power 3. 2 into 2 into 2. Okay? Therefore, the value is 8. Understood? No? Yes or no?
What, sir?
Understood?
Sir, can you repeat?
Understood it or not? Here? Is it
Yes,
clear?
sir. Yes, sir.
Right. Okay. Then 1 into what is the amount? 2 to the power 2.
4.
Sorry?
4.
4, yes. That means 2 into 2. 4. Okay, 4 plus 0 into 2 to the power 1 means 2.
2.
Then 1 into 2 to the power 0, how much?
1.
Yes, very good. 1. For any number, power 0 means 1. Right. Then 8 into 8, 1 is 8. Then 4 into 1 is 4. Then 0 into 2, how much?
2.
Huh?
2.
No, dear. 2 into 0 is 0. 10 into 0 is 0. Any number multiplied by 0, the value is 0. Right? 1 into 0 is 0. 1000 into 0 is 0. Okay? Any
Okay.
number multiplied by 0, the value is 0. This is multiply. This is power 0, not multiply. This is multiply. This is power 0. Two different things, right? Okay. Then 2 into 0, not to the power 0. 2 into 0 means 0. Plus 1 into 1 means 1. Okay? Right. Then we get the answer 8 plus 4 means 12. 12 plus 0, 12. Plus 1 means 13. Right? We are getting a decimal number. 13. Now we can get the expansion of binary as a decimal value. This is how we write the expansion. Got it? Yes. Write this down. Okay. Going to do only one another example, right? මේක කරාම අදට ඇති. Right. Let's say 0, 1, 0, 1. Right? This is my binary number. There are 4 digits. I am going to represent it. Counting frame. What is the position value here?
2 into 0.
Yes. පුතා 2 into කියන්න එපා. 2 to the power. අපි yes 2 into 0 කිව්වොත් මෙන්න මෙහෙම ලියන්න. එතකොට value එක වෙනස්. This is 0. 2 to the power equal 1, right? This is different cases, right? Not 2 into 0, this is 2 to the power 0. Here 2 to the power 1, 2 to the power 2, 2 to the power 3, likewise, right? In this position, right, there is only 1. In 2 to the power 1 position, there is no value. 2 to the power 1, 2, there is only 1. Here, no value. This is how we represent this in the counting frame. Then I am going to expand this 0, 1, 0, 1. Right? Okay. Then first one, 2 to the power 3 into 0 plus 2 to the power 2 into 1 plus 2 to the power 1 into 0 plus 2 to the power 0 into 1. Right. Okay, tell me. 2 to the power 3, how much?
8.
Very good. 8. 8 into 0 plus 2 to the power means 4 into 1. 2 to the power 1 is 2 into 0. 2 to the power 0, how much?
1.
1. 1 into 1. Okay. 8 into 0, how much?
0.
Very good. 4 into 1 is 4. 2 into 0, how much?
0.
Very good. 1 into 1 is 1. Right? 4 plus 1 equal 5. This is from, we get the answer from decimal 5. When we expand 0, 1, 0, 1 binary number, we get the decimal number 5. That's it. Very easy. Write this down.
Okay.
Okay. Now you know how to expand the decimal number, how to expand a binary number, and how to represent a decimal number in a counting frame, and how to represent a binary number in a counting frame. Yes?
Yes, sir.
Okay. I think it is enough for today. Otherwise, it will be overloaded, no? First day, right? Therefore, we'll meet on next Sunday at what time?
11.
Yes, 11. Right. Okay, please go through again what we discussed today, right?
Okay, sir.
Then, okay, thank you. Have a nice week.
Thank you, sir.
Okay.